Hello, myself Divya. Today we are going to read Synthetic Dye Part 3 from Pradeep publication. Article number 8.7 Phenolphthalein dyes. These are obtained by condensing phenols with phthalic anhydride in the presence of certain dehydrating agents such as concentrated H2SO4, ZnCl2 or anhydrous oxalic acid. 8.7.1 Phenolphthalein. Phenolphthalein is a phthalate dye. It may also regarded as triphenyl methane derivative synthesis. It is prepared by heating phthalic anhydride 1 molecule with 2 molecules in the presence of concentrated H2SO4. Phthalic anhydride on reaction with concentrated H2SO4 gives phenolphthalein. Properties. Phenolphthalein is not a dye, it is insoluble in water but dissolves in alkalis to form deep red solution. This is due to the formation of disodium salt which undergoes resonance and hence quinoid structure. When excess of strong alkali is added, the solution of phenolphthalein becomes colorless, again due to loss of quinoid structure and resonance shown below. Phenolphthalein after resonance forms colorless compound. Uses. Because of the color changes shown above, phenolphthalein is used as indicator in acid-base titrations. It is also a powerful laxative. Next 8.8 xanthine dyes. These are derivatives of xanthine dibenzo 1,4-pyran. Important examples are fluorescein, eosine, and rohamides. Fluorescein preparation. It is prepared by heating phthalic anhydride 1 molecule with resorcinol 2 molecules at 473 Kelvin or at 383 to 393 Kelvin. Its presence of anhydrous oxalic acid as a dehydrating agent. Phthalic anhydride on reaction with resorcinol at 473 Kelvin gives fluorescein. Properties. Fluorescein is a red powder insoluble in water. It dissolves in alkalis to give reddish brown which on dilution gives a strong yellowish green fluorescence. Fluorescein on reaction with basic gives fluorescein anion. The sodium salt of fluorescein is known as uranium and dye wool and silk yellow from an acid bath. The color, however, it's fugitive. Next 8.9 Anthraquinone dyes. Elzarin is one of the most anthraquinone dyes. It is the chief constituent of madder root. Mechanism. Elzarin is 1,2-dihydroxy anthraquinone. It is manufactured by phthalic anhydride as follows. Phthalic anhydride on reaction with benzene with presence of anhydrous AlCl3 gives benzoic acid on reaction with concentrated H2SO4 gives anthraquinone. On reaction with fuming H2SO4 gives anthraquinone 2-sulfonic acid. On reaction with NaOH gives sodium salt of anthraquinone 2-sulfonic acid. On reaction with fused with NaOH gives sodium salt of 1,2-dihydroxyanthraquinone. On reaction with acid gives alizarin. Properties. Alizarin forms ruby red crystals melting point 563 Kelvin. It dissolves in alkali to form purple solution. It is a mordant dye and the color of the lake depends upon the metal. Aluminium gives red lake 20 red, iron ferric in a violet black, and chromium a brown violet. Aluminium and iron lakes are usually employed for cotton dyeing and printing, while aluminium and chromium lakes are used for wood dyeing. Next 8.10 Indigo. Indigo is the birthplace of indigo, its official name being indigotin. It is the oldest wet dye known as Egyptian mummy clothes 5000 years old were dyed with it. It occurs was indican, which is the glucoside of indoxyl in Indian plant Indigofran tinctoria and the European plant Itatis tinctoria. The indican on hydrolysis with either HCl or enzymes gives indoxyl, with upon serial oxidation gives indigotin. Indigan on reaction with dilute HCl in the presence of enzyme gives beta glucose or indoxyl. Indoxyl on reaction with aerial oxidation gives indigo or indigotin structure. The structure of indigo has been deduced as follows. First, elemental analysis and molecular weight determination have shown that molecular formula of indigo is C16H10O2N2. Fusion of indigo at low temperatures produces anthranilic acid. Indigo in reaction with NaOH gives anthranilic acid. It suggests that indigo contains one ortho substituted benzene ring in which one position is attached to a carbon atom while the other is linked to nitrogen atom. Third, oxidation state of indigo with HNO3 yields two molecules of isatin. This suggests that indigo consists two identical units joined together and that each unit of oxidation produces a molecule of isatin. Indigo on reaction with HNO3 gives isatin. The structure of isatin has been confirmed by its synthesis as sketched below. Orthonitro-benzoyl chloride on reaction with NaSON gives product and that product reacts with H2O gives final product and thus which react with FeSO4.NH3 gives product after loss of water isatin are formed. On the fourth point, on the basis of the structure of isatin, the following three structures 1, 2 and 3 are possible for indigotin. Fifth, indigotin on treatment with dilute alkali yields anthralinic acid and indoxyl 2-aldehyde. C16H10O2N2 gives anthralinic acid plus indoxyl 2-aldehyde. Formation of indoxyl 2-aldehyde suggests that the two identical units in indigotin are connected through position of 2 of indoxyl moiety with position 3 carries an oxygen containing functional group. These arguments suggest that most probable structure of indigotin is first. Further, X-ray analysis has revealed that indigotin has the most stable trans configuration. This structure has been confirmed by the following three analyses. Human first indigo synthesis. Condensation of aniline with chloroacetic acid produces N-phenylglycine. This upon fusion with NaOH and NaNH2 at 523 Kelvin gives indoxyl, which upon substituent oxidized by air indigotin. Aniline on reaction with chloroacetic acid in presence of heat gives N-phenylglycine. On reaction with NaOH, NaNH2 gives indoxyl. On reaction with O2 gives indigotin. The overall yield of indigotin is low. To improve the yield, a modified method of preparation of N-phenylglycine was used, which is described below. Formaldehyde on reaction with NaHSO3 gives product. This product, after reacted with C6H5NH2, gives a product. This product is also reacted with NaCN, gives a further product, and a further product is reacted with H2O at 343 Kelvin gives N-phenylglycine. Human second indigo synthesis 1896. This involves the condensation of anthralinic acid with chloroacetic acid to form N-phenylglycine orthocarboxylic acid. This, when fused with KOH in presence of NaNH2, produces indoxyl acid with subsequently undergoes decarboxylation to form indoxyl. Aerial oxidation of indoxyl finally gives indigotin. Third, from aniline and ethylene oxide 1943. Aniline on treatment with ethylene oxide from N-phetyl beta hydroxyethylamine, and this upon fusion with a mixture of NaOH KOH at 473 gives the corresponding sodium potassium alkoxide. Second, when the sodium potassium salt is heated with soda lime and a mixture of sodium and potassium hydroxide at 473 Kelvin, the N-odio potassio derivative 3 is produced. This is then dehydrogenated on heating rapidly at 573 Kelvin, and on rapid cooling to 508 Kelvin, ring closure occurs to form sodium potassium salt of indoxyl 4. This upon treatment with water and oxidation by gives indigo tin. It may be noted that synthetic indigo is much cheaper than natural indigo. In fact, synthetic indigo has virtually wiped out the indigo plantation so popular at one time in India. Properties: indigo is a dark blue powder which compared luster melting point 663 Kelvin. It is insoluble in water and most organic solvents. Second point, when a paste of indigo tints is aggregated with alkaline sodium hyposulfate in large vats, the insoluble indigo tin is molten to the soluble indigo compound called indigo tin white. The cloth to be dyed is soaked in this alkaline solution and then expressed to air when the original color is represented on the cloth. Uses: indigo is extremely used for dyeing cotton. The quality of color is excellent and is stable to light washing, etc. It is also used in printing inks. This chapter has been finished.